Let's take an example again. We know the graph of x squared, but let's say we are interested in the graph of 2x between brackets to the power of 2. We know the graph of x squared, so it will be interesting if we can start from the graph x squared and describe how we can get 2x between brackets to the power of 2. Okay, let's plot first both graphs. We can use GeoGebra again. So let's plot first x squared. So that is this one. Okay, and let's plot 2x to the power of 2. And that is the blue one here, the purple one here. Okay, so we have to get from the orange one to the purple one. What I see is if I look at this point here, where x is equal to 2, this becomes 1. And here as well, when x is equal to minus 1, this becomes when x is equal to minus 2, this becomes minus 1. If I look, for example, x is equal to 1, here, in this case, x is equal to a half. And in this case as well. And it's everywhere the same. So what I can see is, I see a compression in the horizontal direction, so in the x direction, with a factor 2. So this distance becomes half of it. This distance becomes half of it. This distance becomes half of it. So the relationship between those two functions will become a compression in the horizontal direction with a factor 2. Okay, let's check another example. We know the graph of the log with base 2 of x. And let's say that we are interested in the graph of 1 over 2 times the log with base 2 of x. Okay, we can check again on GeoGebra. Let's write here the log with base 2 of x. And here 1 over 2 times the log with base 2 of x. So you start again from the orange one and you have to get to the purple one. And if you look carefully, like this point here, where y is equal to 2, becomes y equal to 1. This point here, where y is equal to 1, becomes y equal to half. So what we can see is, we see a compression in the vertical direction. So this point becomes half of it. This here, this distance becomes half of it. So here as well, this distance becomes half of it. This one becomes half of it, because here y is equal to 3, and in the purple one y is equal to 1.5. So everything becomes half of it, and here as well. So the orange one is minus 1, the purple one is minus a half. The orange one is minus 2, if you look carefully, the purple one is minus 1. So here we have a vertical compression with a factor 2. So if we go back, we can describe it as a vertical compression with a factor 2. Let's take another example. We know how to graph f of x equal to 4 to the power of x. Okay. Let's say we are interested in the function, the graph of the function 4 to the power of 1 over 2 times x. So we go again to GeoGebra, and here we fill in 4 to the power of x, and then here 4 to the power of 1 over 3 of x. Okay, let me check it's correct. Yeah, so let's make it 1 over 3 instead of 1 over 2. 1 over 3. Let's go back to GeoGebra, and here we have both graphs. Okay, so we are interested how we can get to the green one starting from the gray one. Okay, if you look carefully, here for example for the gray one x is equal to 1, for the green one x is equal to 3. So we have a stretch with a factor 3. We can check that for another point. Here for the gray one x is equal to 2. And for the green one x is equal to 6. So we have a stretch again with a factor 3. So it's for all those points. So this here is stretched out with a factor 3 horizontally. This one as well, stretched out with a factor 3. This one too. So the function is actually stretched out with a factor 3. So if we go back, we can write down f of x, so 4 to the power of x, is stretched out horizontally with a factor 3. So a horizontal extension or stretch with a factor